Good morning, all of you. Today, we are entering into a new phase. Okay, second unit, wherein we'll be studying wherein we'll be studying types of data, types of variables. How you are going to describe data with tables and graphs. So far, we have seen an overview of data science. Now we are going to get in detail about what are the different types of data we have, how to classify that. Okay, what are the things you should understand about data as such? What is variable? We all have been doing some or the other programs for the last few years. So I believe that I'm very sure that all of you know what a variable is. But if I ask you a question on variables, maybe you will find it very difficult to answer. You know the answer. Most of the things, you know the things, but the reason why we are not able to get good marks in the exams, or the reason why some students keep scoring good marks and some can never score marks, is because they know the things but they don't know how to write it. Okay, so when I am talking to you, when I told you yesterday about what is mean, median, mode, I'm very sure that all of you are almost very familiar with all these things. But when I ask you suddenly, what is a unimodal data set, or what is unimodal, or what is my model, you may not be able to give an answer to that question, although you know what it is. So we'll be concentrating on both the aspects. One thing is that understanding of fundamental concepts. All fundamental concepts should be very clearly understood by each and everybody sitting in this class. Second point is that the concepts whichever you have understood should be written very legibly, very clean way, so that you get full marks for each question. Okay? So it is my, as you have been attending my classes, you know very well that I begin my classes with overview of today's lecture. We'll be studying what is meant by qualitative, quantitative data. We'll be studying what is frequency distribution. Yesterday we have seen an introduction to histograms. I told you that in future lectures I'll be going in depth about histograms. So today we'll be seeing some more things about histogram and frequency polygons. How to construct histograms, how to construct frequency polygons, and all these things will be dealt with in today's lecture. And variables, I told you, all of you know what a variable is, but we have two types in general, not just, this is one way of classifying variables. We have multiple ways of classifying variables. One way, and the most common and most precisely used ones, is classifying variables into discrete variables and continuous variables. So in today's lecture, I'll be explaining to you with examples what are discrete variables and what are continuous variables. Okay, then we'll do some practice problems, and then I'll keep asking you certain interesting questions which I would be happy if you could give me answers about these questions that is being asked. Okay, so let's proceed. So first thing, what is classification of data and why is it classified? So first thing is classification of data. You are organizing it into categories based on their characteristics. You are organizing the data based upon its characteristics. So you are segregating data into different types. When you were studying Python basic classes, you would have learnt about the types of data. Integer classes, string types, right? You might have learned about the object-oriented programming structures and so on. So in all these things, you would have learned, as far as Python is concerned, it is not the data types, it is all objects. We have strings, we have integers, we have double, we have float, okay, we have boolean, we have multiple type of data. So that is the reason why we are classifying data. The two main types we are classifying it like this. One is qualitative data, another one is quantitative data. A data is said to be qualitative if it describes a quality, not in terms of numbers. Okay. If I ask you to describe your chudidar, what you will do? You will tell it is black in color. That means that it is a quality of your dress, right? If I ask you what is your marks in the exam, you will tell me 98.6 or something, right? So this is quantitative. Quantitative is a measurable data, it is always numeric. Qualitative is not numeric, you don't have a numeric value for this. You give it as a, what do you say, a generic one. It's called as categorical data. It can be categorized into certain norms. Okay. So whenever you have a question, how much? What is the distance from your college to a city? It's how much? It is numeric data. It is a quantitative data. But if I ask you, say for example, whether, how long or what is the, what do you say? I'll give you, what is the color of your dress or color of your something? It's a categorical data. It does not have any value. Or if I ask you what is the season today? Okay, you can say it is sunny, cloudy, rainy, and so on. Right? How is the climate today? What is the weather today? How would you give me an answer? In general, you would give me a categorical answer. Sir, it is very sunny, it is very cold, it is very hot. Okay. So hot, cold, all those things can be categorical ones only. But if I ask you what is the temperature today, you will give me 32.6 degrees Celsius and so on. So that is numerical data and that is quantitative data. So qualitative, categorical data, non-numerical descriptions, measurable quantities. You have categories of labels. Say one example here is gender. Okay, in data you have male and female, right? That's only categorical data. You cannot tell how much male and how much female it is. You can tell the number of males and number of females, but you cannot quantify it, right? You cannot quantify colors. You cannot quantify blood type and so on, right? It's all category. What one definite set of categories. Blood groups. If I wanted to collect all the blood groups, it's all only a quality. This is just a quality. You don't have any numerical value for that. This is the first or the direct way in which you will be studying how data is classified. There are multiple ways in which you classify data, but for our scope of study, we are limiting it only to this kind. So what is qualitative data and what is quantitative data with examples? I told you already that you understood what is qualitative data. I'm very sure about that. But how do you write these things in the exam? What is qualitative data? If a question is being asked, how you write it in the exam? That's what this particular slide describes. So we were discussing about what is meant by qualitative data. So we were discussing about what is qualitative data. I hope you have understood what is qualitative data. I've given some examples: gender, marital status, single, married, divorced, widow, separated, or something like that. So these are all categorical data. That means that you have a category of things in that particular data set, right? So, for example, even this pass and fail, pass and fail is a categorical data. I have a database of all the students, each student, how many students have passed, failed. So I can categorize the students as pass or fail. That is why it is called as categorical data. It's a quality. We are not, we are, how much pass you can't tell, how much marks you can tell, but you can tell that the student is pass or fail, that's all. Right? Same way you can tell whether a person is male or female. There's only a category of that. You cannot quantify it. The things that we cannot really quantify, we call it as qualitative data. And these are the areas where, see, whenever I'm teaching you, I'm giving you another one more important thing is that I'm teaching it in such a way that it is going to be very helpful for you in interviews also. Our question papers, your placements, your internship, even if you would like to have a, we are planning to build a career for you. Okay. The basic idea is building a career. So, these are the type of questions that you may find if you would like to apply for a post of data science in any of the companies. Post of data scientist, I'm sorry. You'd like to apply for a post of data scientist in any of these companies, you can see that you'll get these kind of questions coming up. Okay, I want to do this. How can you do that? Is it a categorical data? This is a data set I wanted to process on. How would you do that? So these are the things that you have to keep in mind. Our examinations, our system completely is focused so that you have an industry interaction, you have an industry orientation. How a real-time project works. Okay, how you are going to work in a company, how you are going to start, how you are going to build your career in future. So it is very important that you are able to understand every nook and corner of whatever is being taught. I believe it is very clear. If a data set is given to you, you can very easily classify this as categorical, qualitative data, or based upon the categories, right? Suppose you are classifying some people as poor, middle class, upper class. This is qualitative data. You are classifying people based upon the income, then it is a numerical, quantitative data. Those people who are having more than 5 lakh annual income. Now that more than 5 lakh, it is an categorical, but you are asking a numerical thing, then it is a Quantitative, what is your annual income? So you're saying 5 lakhs, 6 lakhs. So that's a quantitative this thing. We can convert this into quantitative into qualitative by giving ranges. Okay, I'm classifying people below 5 lakh as per 5 to 15 lakh as middle class, above 15 lakh as upper class. So I'm converting this categorical data into a numerical data into a categorical data. So for qualitative data, we often use bar charts and pie charts. The very important point that you need to note, because you should understand for which type of data, which chart would be most suited. Whenever you are using qualitative data, you can use bar charts, pie charts, etc. It's a very important question. This might probably pop up in many of your interviews or objective questions. We prefer using bar charts and pie charts because it's very easy to. Whenever I come with my Python classes, I'll draw these graphs and show you. I'll give you some example data sets. In the previous class, we discussed about uh, box plots, so on, Weiling plots, all these plots, heat maps, all these things are very easily drawn in Python. So I'll give you an example and I'll teach you how to draw or how to represent that particular data set visually. For that, I need the help of Python. That will be useful for you in your data science lab also. So qualitative is done, quantitative is measurable. Quantitative data represents measurable quantities that can be expressed as numbers. How many, how much, and so on. The number of students who have passed, number of students who have not passed, the height of students, weight, temperature, age, salary, etc. We use histograms or scatter plots very often to describe, to visualize quantitative data. We describe or we visualize quantitative data commonly with the help of histograms and scatter plots. More about data visualization we will be studying as we go on. Okay. So I believe that everybody has clearly understood what is quantitative and qualitative data. Am I right? You can raise your hands for any questions in between, or if you are happy with, you have understood everything, you can allow me to proceed, I will proceed. Is there anybody who wants more explanation on whatever is being taught so far? So, shall I go to the next? So now, categories of data, what you're going to do. We'll be studying 4 types. There is 4 types, very important ones, which is almost asked in every way. So in all kinds of research, wherever you go in research methodology and in such kind of subjects also, you can find these, the ways in which data is expressed, the different scales. What is meant by nominal scale, ordinal scale, interval scale, ratio scale? I put it in a simple order. From top to down you go. There is more information in each as you go from top to bottom. What are the scales? We'll be seeing in the coming slides. We'll define all these scales. And we have a great amount of applications in this also. So what is meant by nominal scale? Nominal scale usually represents categories with no inherent order or ranking. It's the simplest level of measurements. So nominal scale is directly, you're giving a categorical data directly. The categories are mutually exclusive. What is meant by mutually exclusive? You cannot have a person with both A and B blood groups. Of course, here you can include transgenders also. Transgenders, if required. A person can either be male, female, or a transgender. He cannot be two at the same time. Blood types, he can be two. Marital status, he can either be single, married, or divorced, or separated, or something like that. Colors, it can be either red, green, or blue. So, it simply means to say that it is a person, this category, one person cannot have two categories. When it comes to nominal scale of representing this data, these are all different ways of representing data, okay? The first one you are learning is nominal scale, the simplest way of measuring things. You don't have any particular meaningful order for this, so that this particular order is going to define certain things like that. All data is simply labeled. There is no, you cannot do any major calculations with arithmetic operations, okay? We, of course, we find the probability, we do that, but there is no major arithmetic operations which is really meaningful. What we do certain things, we find the probability and certain things, but that's not very, really very useful. Okay. The next one is the ordinal scale. In the previous one, nominal, the data was not ranked, categories was not ranked. Here we have a meaningful order or ranking. But the difference is that categories are not uniform. Okay. Categories can be ranked. And the order is very important. In the previous case, in the nominal scale, the order is not very important. The differences are not equal. And arithmetic of operations like the previous one is not very meaningful. So you have a higher one, PhD higher, masters, bachelor's, high school. So you are classifying it in terms of levels. So you have an order. In nominal scale, this order doesn't matter. But in ordinal scale, you have an order. Highly satisfied, dissatisfied, very much, and so on. Grade, mark, A, B, C, and so on. Economic status, I told you, higher, lower class, higher class, middle class, and so on. So you have this, and in a particular order. Okay, the categories need not be uniform, but okay, it can be as you like it. So ordinal scale, these are the different ways of representing data. Nominal scale, ordinal scale, and the third one is the interval scale. Interval scale. Here we give a particular set of intervals to the values and then we mark it. So represents numerical values with equal intervals but no true 0 point. Equal intervals between values. So 20 to 30 degree, 30 to 40 degree, 40 to 50 degrees. Suppose I am having days classified as in the interval range. Okay. So I want it to be specified in a particular range. How many days were hot, cold, and so on in a month? I want to classify it. I use an interval scale. There is a below 20 degrees, there were 10 days in this month. At 20 to 30 degrees, there were so much days in a month, and so on. That's why we say we have an interval. Now, in the ordinal scale, I am giving classifying students as slow learners, average learners, and fast learners, for example. Okay, you have a slow learners, above that you have average learners, above that you have fast learners. Okay, I'm classifying students. When I come to this interval scale, what I'll do is that I'll give intervals. So many students, 90 to 100, 80 to 90, 70 to 80, 60 to 70, 50 to 60, 40 to 30, and so on. Okay, so this is more clear. The data is more clear. Certain arithmetic operations like addition and subtraction may not be meaningful. Ratios are not meaningful. Okay, so you have something called a Likert scale where you have what I told you about the satisfaction grade. See, you might have seen that if you are fully satisfied, mark 5. If you are somewhat satisfied, but you find it good, I mean, excellent, very good, good, okay, bad or poor, very poor, and so on, right? Yes or no? That type of rating. You put numbers for excellent, say you put excellent is 10, okay, and you rate in the scale of 10. You might have seen whenever you do certain, if you even install certain softwares or you see in your mobile apps and all, you can see how are you going to rate it. The app you are using, in Play Store, you will be asked to rate certain apps, right? 5 stars, 4 stars, and so on. That's a kind of scaling. Okay. So the Likert scale is similar scale, but instead of 5 stars, you give some numbers to that. Next is a ratio scale. The ratio scale represents numerical values with equal intervals and a true 0 point. In the previous interval scales, we didn't have the 0 point, but today, in the ratio scale, you really have a true 0 point. It is the highest level of measurement. Equal intervals between the values. Absolute zero exists. All arithmetic operations are meaningful. Ratios are meaningful. So we prefer ratio scale in many cases where we need to have some arithmetic operations and so on. See, this part is purely theoretical, and when you do this practically, you will really understand why you are studying all these things. Okay, this is a theory session, so we'll be handling only the theory part of it. When we come into practicals, I'll give you some case studies. If I give you say some data set and I give you to analyze, you will understand why we are going up with the kind of scaling options and so on. But this is theory and you have to understand this. You may get these questions in your exams. So you need to prepare for this for sure. So we can find the average height, average weight, average age, income, number of students, and these things will be highly meaningful in ratio scale. I presume that the four scales are very easily understood by you, right? Is there anybody in the class who wants further discussion on this? We'll do more practicals. I believe that there are certain more things that you need to understand on all these topics. We'll do more practical, some programs, and you can learn more on that. So this is an example. As you go on, the information is higher and higher. In ratio, you have the exact values. In interval, you have a range of values. In ordinal, also, you have a range of values. In nominal, you don't have any range of values. This is a very simple chart to make you understand the type of scales and how the scales are being classified. Is there anybody who wants further discussion? You can please open up. So here we have classified data into qualitative and quantitative. For qualitative data, we prefer nominal, interval, ratio. An interval can be used for both quantitative and qualitative data. Ratio cannot be used. Ratio we don't use. Qualitative data. Categorical data we don't use. So data usually for nominal and ordinal are almost the same. Similar, there is only a few small difference. So if the data is qualitative, we prefer nominal, ordinal, or even in some cases interval. But in quantitative, we prefer interval and ratio. So basically, in the first part of today's lecture, I've given you a brief introduction about types of data and different ways of arranging data or scaling up data: nominal scale, ordinal scale, interval scale, and ratio scale. The next part of this lecture, I'll be giving you an introduction to what is a variable, something which is very similar to the types of data. Okay, but it's all numeric here. Okay, so variables are those characteristics which can take different values. I told you already that we have xi giving yi. Okay, so this x and y are variables, and we have two types of variables. One is called as discrete and the other one is called as continuous variables. Okay, easy to remember, and the best way of understanding what is a discrete variable is that continuous variable you have values at every point. Discrete variables you don't have values at every point. You have at particular points. Discrete variables, there is a possibility of having an input but no having giving an input for no output at all. In continuous variables you have output points at every input point. Okay, so discrete you have countable variables. You have already done no, in probability, statistics, in so many places you would have studied what is discrete and what is continuous. Okay, so the graph looks something very similar for discrete like this. It's all based on points. For continuous, it is something like this. You have values continuously. Suppose this is x and this is y. You have data points at for every value of x, you have a value of y output. Here, not for every value of x, you are having an output y. So discrete is a sampled output of the continuous variables. Discrete values, you have separate values at each point of time, or not necessarily time. If time is one variable here, we generally take it as time. Okay. So you are plotting the graph between time and vehicle moving, right? So it is continuous, right? Every point of time you have a speed value, right? That's an example for continuous values. For discrete values, I can give you more examples. the number of times something has been, the vehicle has stopped. Okay, so for n, you have only one value at one point. There are some points where you don't have any values. So we'll see more into what is discrete and continuous variables. Definition for discrete variable: it has finite or countable number of values. Say number of students, number of cars, books on the shelf, number of children, and so on. So you have countable values. These are all numbers. So you don't have any values between 0 and 1 in the number of students. I cannot say half a student and so on, right? So you don't have decimal values, you don't have continuous graph. Okay? When I'm plotting number of students with respect to something else, not all values will have an output. Maybe there is x point 10.5 or 1.5 is not a valid number. But if I'm plotting between marks and your this thing, now I'll get every value. Every point you have a value. Yes, you can have 5 students but not 5.5 students. So you have a finite, countable one that is discrete. And we'll be working a lot with discrete and continuous variables. I believe we have already studied probability. You know what is probability distribution function? PDF. What is cumulative distribution function? I want you to just revise all these basic concepts when you come for the coming classes, because we may need to do a lot of problems based on probability and statistics. There is no data science without probability and statistics. And we may not be having sufficient time to go much deeper into the basics of engineering mathematics. So I advise you all to refresh your memory on probability and statistics whenever you come to my classes in future. Okay? So continuous variables can take any value in the given range, right? You have decimals, you have continuous values. Height, weight, temperature, time. And time is the most common one that we always use. Time. Because time is continuous. You never have a break of time at all. Okay, time is moving and it is always moving forward. So continuous variables take measurable values. Qualitative, quantitative data, discrete, continuous variables. Okay? These concepts are different. Don't think they are all the same or something, there is more similarity. No, it is not like that. If you think carefully, you can understand. Variables are in itself not, it is only a container for values. Okay? X can have n number of values. You take X in your program, whenever you do a variable, X can be 2, X can be 3. I posted a problem yesterday. How many of you tried doing it? One Python question I have posted, in which X is a variable. X is equal to 3, X star star equal to 3. Print X. What will be the output? I have asked this question in your, I think I posted that. Now you have seen, how many of you have seen that? You can give it answers as comments in that itself. There's no problem on that. Okay. I've given you the question, I'm trying to get the answer. It's a multiple choice question. You have seen that? No. So please check that out and give the answers so that you can see whenever I'm posting a video or posting a material, it is so that I have something in my mind for the next class or coming up sessions. Okay. So if you do that, today it would have been very easy for me to explain to you what a variable is if you had simply solved that simple program in Python. So just taking up the summary of discrete and continuous variables, values are countable and measurable, type are whole numbers, value can be decimals in any range. Usually it is decimals. Any number that can be represented as a decimals is usually a continuous variable. Very finite set, infinite examples, students, number of students, cars, and so on. It can have fractional values. No, discrete cannot have fractional values. Continuous values are mostly in fractional values. Number of students in a class is a discrete set. Temperature of body is continuous. Books on a shelf is discrete. Time taken to run, continuous. Time is always continuous. Anything that relates to time is always continuous. Anything that has an input as time is always continuous. So next, again, about representing data in different formats. What is meant by frequency distribution? What is frequency distribution? It's a way of organizing data based upon the number of observations. I have a data set of all the students in your class. I am making a frequency distribution of these marks and the students. 80 to 90, 10 students. 70 to 85 students. 60 to 70, so many students, like that. Here I am not having the exact value of marks of each student, but I am only having number of students that fall in a particular range. This way of representing data is called as frequency distribution. Okay. Say I have 4 students, A, B, C, and D. Okay. A has scored 70 marks. B had scored 75. C had scored 90. D has scored, say, 60. So when I say 60 to 70, I am giving only 1. I am not having C, D's mark, but I am having this number as 1. 70 to 80, I am having 2. That means 2 students have scored between 70 to 80, 70 and 75. Okay. 80 to 90, again I have only 1 student. Okay. That is the C. So I have represented the entire data set in terms of a frequency distribution. But here I cannot know the marks of individual students, but I can only know the number of students who have scored particular marks, who have scored marks in a particular range. So you display the number of observations within a given interval or categories. This is used to organize large amount of data. Okay. Here I have given you a very simple one, small one. The data set is large. This is going to be more useful. organizes data into meaningful form, shows how data is distributed across categories, helps in identifying patterns and trends. So you have class intervals, you have number of observations in each class, you have proportion of observations, total number of frequencies. But make sure that frequency distribution, you are not representing the exact data. So example set here, I have a class of 20 students, 60 to 100 I have put marks. I have calculated the number of students in each range. Then I have calculated relative frequency. Coming to histogram. Histogram is the best way of describing or displaying, visualizing a frequency distribution chart. Here the data is grouped into intervals and represented by bars. The bar height represents the frequencies. Bars are adjacent, you don't have any gaps. Horizontal axis shows class intervals. Vertical axis shows the frequency. This is in general, okay. You have the bar charts or you have histograms the other way around also. And we have advanced tools and softwares which can easily create histograms. I will be giving you some examples in Python using matplotlib.py plot library, where I will be describing your marks in terms of histograms. So we are using this to distribute continuous data, identify the shape of distribution, find central tendency and spread. So this is all about histograms. Here I am giving you an example of histogram. You have an interval value 60 to 69 with one frequency. So the height of the bars represents the frequency of occurrence of a event. The distribution appears roughly bell-shaped in normal. See, yesterday while discussing, I told you about the importance of Gaussian, right? The bell-shaped ones. Usually you have the histograms also coming up in this kind of bell-shaped ones with a kind of symmetry. This side is equal to this side. Okay. So this also you can see as we go towards the central. I told you now the students, number of students who have scored low marks, maybe say I'll show you this like this it comes, the students who have scored from 0 to 10 will be less. I mean 0 to 25 or 30 will be less. From 30 to 70 will be always high. And above 70 will also come down, right? This is the case in most of the things that appear naturally. If I put your heights also, very short people will be less, very long, very tall people also will be less. Majority of them will fall in the central range. This is universal and this applies everywhere, not only for marks, not only for brilliance, not only for height, so many things, even for weight also. People with very low, small, very light people will be less. Very heavy people also will be less. Most of them will fall in the central range. So every these things will become a bell-shaped or Gaussian type. Okay, that's what is being told here. And please make note of all these examples. You may be asked to write questions with examples, and you need to write it and draw it and show it. Okay. So after this, we'll learn what is frequency polygon. Like histogram, frequency polygon is also a method of graphically displaying frequency distribution where points are plotted at midpoints of intervals and connected by straight lines. The definitions may be asked directly or indirectly in your exams. If a definition is asked, you need to write the definition answer. So please make note of these things. It is not possible for you to remember everything. And also, you may not be able to watch such long videos continuously. It's always good that you refresh your memory whenever you are taking rest. You can use the YouTube videos. If you are absent also, I suggest that you go with the videos and just have a look into all these things. Midpoints, intervals connected by straight lines. So points at interval midpoints connected by straight lines shows the shape of distribution can overlay multiple distributions. So this is a frequency polygon. Okay. So it is represented by these kind of lines. Okay. Shows the same distribution as in the case of histogram. So that's what is meant. It says that points at interval midpoints connected by straight lines and shows the shape of distribution can overlay multiple distribution. Okay. So what do you mean by frequency polygon? Explain with examples. You can get questions like that in your exams. So it's always suggested that you keep yourself prepared for these kind of questions and the answers. So this is an example here. Here, when compared to that histogram, here I'm putting these lines, I'm connecting this here, 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 connecting by straight lines. So this is called as a frequency polygon. So now I have a question for you. Identify and outline the type of data for each of these things. Blood types. I am classifying the whole a set of people based upon their blood groups A, B, B naught. So what type of data it is? It is always categorical data, easily represented by nominal scale, right? We have seen that most of the qualitative information we use nominal or ordinal scale. Even if you have written the answer as ordinal scale, you get marks for that. Ordinal scale is not a wrong answer. But interval and ratio, can you represent blood groups by intervals or ratios? No, it is not possible. Unless and until you give some values to certain things, you cannot do it. So we go with nominal or ordinal scale for representing this kind of values. Categories have no inherent order or ranking. You cannot say which blood group is better, A blood group or B or O. Which is good, you can tell. No, you cannot tell. All are equally ranked. So you don't have any kind of grading with that. Right? So that's the reason why this is taken to be a nominal scale. Here this is numerical, number of books on the shelf. Here you can give a ranking. In one shelf there is more number of books. In one shelf there is less number of books. So there is ranking here. But when you compare that with the blood groups, you don't have any ranking with that. Right? So differentiate between continuous, discrete and continuous variables might be very common question in your exams. You can note this down and you can write the answers like this so that you get more marks. Always your answer sheets should be presentable and easily readable. An exam which you are writing for 2 hours or 3 hours or 1.5 hours is being evaluated in less than 1 or 2 minutes. In most cases. Okay. So you have to keep in mind that your answers should be very readable, represented. More diagrams, more charts, more tables, you get more marks. It's one of the most important tips that I'm giving to you for writing exams. This does not apply for data science alone. It applies for all your subjects, whichever you are learning. You need to represent your answers more in terms of diagrams, tables, equations, and charts to score more marks. So if a question is asked, distinguish between continuous and discrete variables, you can write it down in these kind of points so that your evaluator can easily give you more marks. Writing lots of stories and paragraphs will not really fetch you good marks. So I actually wanted to blur these things, but scale of measurement, qualitative, ordinal. So I'll be giving you some assignments based on this. That's the reason why I put this slide as such. I'll give you the, say for example, I have a data set of grades, whether it is qualitative or ordinal. I'll give you a quiz in Google's form so that you can answer these things. Okay, so you can have a review of this. You can go through the video and say, if you have any queries, you can ask me. Or if you have really understood these concepts, I can proceed. Temperature in Celsius, weight in kilograms, socio-economic status, and what is this? So this naturally will be qualitative, right? Because you have grades, you have marks. This will be quantitative because it has numerical values. This is numerical values, qualitative. This does not have numerical values, so what it is? It is qualitative, right? The numbers with these things will be quantitative. Quantity means numbers. Okay. So weight, the best way, ratio, ordinal. Okay. Representing in terms of scales. Another one, number of emails received in day, whether it is discrete or continuous. Numbers. There can be days when you have received no emails at all, right? So you don't have values for all inputs. So it is discrete. Distance traveled to work in kilometers, it's continuous, right? Why it is continuous? Because it can have decimal values. Number of pages in a book, discrete values. Because why is it discrete? Fixed values, right? It does not change, no? You cannot have half a page. You cannot have decimal values. So in most cases where you don't have decimal values, it is discrete. Time, wherever you see time, you can be sure that it will be continuous. Okay, because you cannot break the time. Unless you create something exclusively for that, in all normal cases, majority of the cases, 99.99% of these cases, time always falls under a continuous category. But there might be certain exceptions if you really make it out in such a way that if you make it into intervals or something like that. And otherwise, it is always continuous. Number of people, whenever it is numbers, it is usually discrete. Countable whole numbers. So identify the scale of measurement for each of the following. Rank of a student in the class. It's usually ordinal scale because you're ranking it. It is not marks, it is ranking. Eye color, still it is a category, categorical, right? So whenever it is categorical, it is nominal. Salary, numbers, decimal points, so it is ratio. Mood rating, whether happy, sad, or you go with ordinal. In most cases, it is ordinal. So write this down, and I would like you to have this being solved when it comes to the next class. I have the answer for this and the next slide, but I would like you to do it from yourself. Check out your understanding and discuss it tomorrow. In tomorrow's class or the next class, I will ask some of my students to come out and give answers for this. So I want all of you to make this note and do it and come exactly tomorrow itself. Okay? Are you able to understand what I'm saying? All of you? So please make a note of this. I would like to have a discussion with you. I would want you to interact with me. I want you to come out and give me the solutions for this. If you could comment it on my YouTube also, it's okay for me. You can comment the answers in YouTube also. I'll try to post it today. I have one thing pending, the previous class pending, that and this I'll post it today. Shall I go to the next one? This is the answer, and I want the answer in this format, okay? Whether it is qualitative, discrete, ratio, or what type. This is another one. I want you to draw the histogram. I'll teach you how to create a Python program for this. So initially I want you to do it manually. Create a histogram for this. This can also be included in your assignment. For all those students who are actively working out with assignments and these kind of questions and answers, I'll be giving you more internal marks. Okay? For active answers, active involvement. Each one of you will have different type of questions, different kind of level of understanding and different level of working. So I've given you the frequency distribution histogram, and of course it's very easy for you to create a frequency polygon also for this, right? The answer is there here. I'll show you the answer. This is the way the frequency distribution table is created. Okay, frequency, relative frequency. Even if you are not able to work with relative frequency, it is okay. You don't need to do it. Frequency and this is enough. So from this, what we come to understand is majority of them are in the range of 30 to 34. That's what it says. It's a distribution is roughly symmetric. Symmetric means what is that? You understand? I told you now for Gaussian distribution, when I say Gaussian distribution is symmetric, this is, let me call this as mean, or this is a center. Symmetric means this side is same as this side. Okay? The part towards your left and your right is same if you draw a central line. That's what is called as symmetric. So distribution is roughly symmetric. So I've drawn the histogram of employees' ages. This can be considered as your assignment, and you can submit it separately either through your classrooms or as a hard copy to me, either way. I prefer using classrooms. So these are certain set of questions that you need to, so far we have discussed that, okay. Scales of measurement, difference between discrete and continuous variables, frequency distribution, what is the difference between histogram and a frequency polygon, okay, some examples also. Summary of today's lecture: qualitative, quantitative data, then 4 scales: nominal, ordinal, interval, ratio, what is meant by discrete variables, what is continuous variables, what is frequency distribution, histogram, frequency polygon. I am displaying to you the summary of whatever I have done. See, each and every slide that I am preparing is prepared with lot of effort. Meticulously I am doing it. You really know that when you start doing this, you will understand. If you are in my shoes, you will know that it is very difficult to prepare in spite of all this. Okay? So each and every slide has a purpose. And every lecture is being very systematically planned for me. So I might give you some hints before also. Like I told you, yesterday I've posted a Python question in my from my YouTube channel to your WhatsApp groups so that you can answer that. So the purpose of including the summary slide is for you to revise on whatever is being taught today. And it's a quality time for discussion. Your time is very precious, like mine. Your time is very, very precious. So I want you to really understand, discuss, and come out with your problems in the academic part. Okay, if you don't understand anything, you want something to be explained again. So when you see the summary, you will think, oh, I didn't know anything. You can ask me. That's the thing that last 1 or 2 or 3 slides are meant for. It's a revision of what we have done on that particular day. So if you have any kind of queries, any kind of discussions, you are very free to open up. I am more than happy to give you answers for all the questions whichever is possible from my end. Any queries? Anything that you want me to explain again? This is repeated. Huh? So these are the topics that is being covered today. Thank you very much for attending this lecture. And we are just moving towards the 3rd unit. 2nd unit is halfway around. Maybe it requires 2 or 3 more lectures. Thank you very much for listening to me. And see you very soon in the next lecture.